All right, let's go. Good morning, and today I'm presented on the topic, do topics make a metaphor? Topic modeling for metaphor identification and analysis in Russian. Cognitive linguistics and cognitive science in general recognize metaphor as a powerful tool which is ingrained in the human cognitive system with which we process and conceptualize the reality around us. And as a consequence, metaphor forms a fundamental part of the language system and is present in virtually every stretch of discourse. Since metaphor is based on duality, it becomes a major source of ambiguity in natural languages and therefore poses a serious challenge to many NLP applications, such as information retrieval, machine translation, question answering, information extraction, and others. The relevance of metaphor in NLP is illustrated by the large and growing number of publications, the dynamically growing...
in un attimo.
Sorry?
In un attimo.
Yeah, please continue.
Mm-hmm. By the dynamically growing research community, the regularly held workshops on metaphor and other figurative language, and by the competitions for computer systems for identification of metaphor detection, which have already been held twice. So the following features are exploited in machine learning experiments for metaphor identification: lexical, morphosyntactic, distributional semantic, psycholinguistic, such as automatically obtained indexes of concreteness and abstractness, some manually curated resources such as thesaurus and thesauri and ontologies, and topic modeling, which is the focus of today's talk. So the application of topic models for metaphor identification relies on the theory of conceptual metaphor, which states that metaphors are conceptual schemata or cognitive patterns which are manifested in language in the form of linguistic metaphors. For example, the conceptual metaphor poverty is a disease where poverty is the target and disease is the source can be exemplified by the linguistic metaphors. The epidemic of poverty is spreading in America and we can't treat the symptoms of poverty in isolation. So when applying topic modeling to metaphor identification, we expect that topics will be acting as proxies for these conceptual domains, the source and the target. And therefore, metaphoric contexts should contain terms from both source and target domains, while non-metaphoric contexts will contain only the source. And thus, metaphorical discourse should be thematically more heterogeneous than non-metaphoric. Previous work on topic modeling for metaphor identification is summarized in this and the next slide. The two experiments presented here identify metaphor on sentence level in English, Spanish, and Farsi with LDA models and rule-based classifiers. They demonstrate the performance ranging from 60 to 73%. And Kubanov and colleagues identify metaphor on word level in English, along with other features, and they show that topics is the second most effective feature after lexical unigrams. Topic modeling vectors were also suggested to participants of the first and the second shared task on metaphor detection. Now to our experiment. We trained two types of topic models. The first is the classical conventional LDA model, and the second is the ARTM model. This is topic model with additive regularization. We apply different regularization coefficients to obtain a sparse and a dense model. Regularization allows reducing noise from stop words, general vocabulary, and other high-frequency words, and results in more interpretable topics, since each term is assigned to a relatively small number of topics. The topic models are trained on approximately 600,000 randomly sampled entries from Russian Wikipedia. The data was cleaned using the corpus tool. Lemmatization and post-tagging was carried out with the PyMorpho2 library. Bigram collocations identified with GenSim. Wikidata was vectorized using count vectorization, and topic models were incorporated with BERT embeddings by concatenating topic vectors with average BERT vectors. Our metaphor identification experiment is run on the metaphor annotation corpus, which goes under the working title Rusmet, which is comprised of about 7,000 sentences, each of which contains one of the 20 polysemous target verbs, such as to bombard, to attack, to weigh, and others. These sentences are divided into two classes, metaphorical and non-metaphorical. This slide presents sentences with the target verb to explode. Xenophobia is what may become a ticking bomb which will explode our society, is a metaphoric example, or also it was necessary for her to explode the situation by any means. And a non-metaphoric example, the commander-in-chief gave orders to explode the remaining fortifications and to flee the town. We identify metaphor and sentence level by classifying it into two classes, metaphorical and non-metaphorical. We played around with several conventional machine learning algorithms such as SVM and logistic regression, and a simple neural network, multi-layer perceptron. More sophisticated deep neural networks were not applied for two reasons. Firstly, the relatively small size of the corpus, and secondly, because the learning features are represented as non-sequential. They are represented as bags of features. The models were trained and tested using 5.5-fold cross-validation. The results of metaphor identification with topic models are presented in this in this table. We compared models, topic models, with the number of features ranging from 40 to 90. However, the models with 60 and 70 features did not perform that well, so they are not presented in this slide. Overall, we see that in terms of accuracy, logistic regression performs slightly better on the non-regularized LDA model, while in terms of F1 score, SVM shows somewhat better results with the ARTM models. We also carried out a feature ablation experiment by replicating the classification feature suggested in the 2019 paper of Badryzlova, and we compared their performance with and without the topic model. So the additional features are lexical. Conc is concreteness and abstractness, sem is distributional semantic, and pos is morphosyntactic or part of speech. When comparing the performance of unifeature models, we see that the simple lexical baseline performs better than anything else, this result does not come up as a surprise because it is consistent with previous work, for example, by Klebanov and colleagues for English. As for the performance of topic models, we see that its performance is more or less comparable with the other features. Overall, the highest results are obtained by combining 3 or more types of models, for example, here. To evaluate the contribution of topic models, we ran a statistical significance test, which showed that the statistically significant increase occurs only when topic models are combined with concreteness and abstractness features. In all other cases, the increase is not statistically significant. Now, what do topic models tell us about metaphor? It would be natural to expect that a metaphoric and non-metaphoric, well, it would be somewhat natural to expect that metaphoric and non-metaphoric discourse differ in their topical composition. That is, they contain different sets of topics. Oh, sorry. However, when we run a statistical significance test, the Kolmogorov-Smirnov statistic, it does not corroborate this expectation. However, this does not mean that topics are distributed uniformly in metaphoric and non-metaphoric discourse. A closer look at the distribution of topics in metaphoric and non-metaphoric subcorpora reveals that some topics are more characteristic of the metaphoric discourse, while others occur more frequently in non-metaphoric contexts, and yet others occur equally frequently in both subcorpora. The topics are listed below the graph on this slide. So literature and writing, economy, judicial system, corporate management, and so on. How does this comply with our initial hypothesis that topics may serve as proxies for the conceptual domains of target and source? The answer is they don't. They do not comply with this postulate of the conceptual theory, metaphor theory. How the identified topical cues seem to reflect certain broadly defined realms of reality rather than the more fine-grained conceptual structures. Yet they demonstrate that differences do exist in the topical profiles of metaphoric and non-metaphoric discourse, which is an encouraging result, calling for further investigation. Now, what about our second hypothesis, that metaphorical discourse is thematically more heterogeneous than non-metaphoric discourse? When we look at the entire data set of 20 verbs, this assumption seems to be corroborated because the average number of topics is significantly larger in metaphoric sentences. However, when we look at individual verbs, the trend holds only in 11 to 15 cases. For example, the verbs to prick, to iron, and to comb have fewer topics in the metaphoric discourse, in the metaphoric subcorpus. We think that this is due to the fact that these are verbs of everyday physical events when used non-metaphorically, and emotional reactions when used metaphorically. And these are topics which are underrepresented in the training Wikipedia data. And subsequently, the profile analysis further shows that the behavior of verbs is inconsistent. and therefore the hypothesis cannot be fully corroborated. Summing up, the performance, the accuracy of the topic model of the classifier based on topic models is around 0.7, which is comparable with other features, with the exception of the lexical baseline. However, adding topic models to other features improves performance only in one case when combined with concreteness and abstractness. Topical cues of metaphoricity do exist. However, they do not reflect source-target mappings. The hypothesis of metaphoric contexts display greater thematic heterogeneity is not sufficiently corroborated, and we think that we need topic models trained on other corpora other than Wikipedia, for example, fiction, to capture the currently underrepresented topics and figurative usages of words. This is the end of the talk. Thank you for your attention. Questions are welcome.
Thanks a lot. And yeah, we have plenty of time for questions. There is actually one question in the chat from Yaroslav Polansky. Or Yaroslav, maybe you want to ask it in person if you're here? No? Okay, so the question is, slide 11 says that you have average topic vectors with word embeddings. Was this done to get away from the bag of words model, or was there another idea?
Oh, I'm sorry, I checked. I think I need to. Slide 11. Actually, I cannot give a definitive answer. I don't think I can give a definitive answer to this one because the models were trained by my colleague Anastasia Nikiforova. So I might ask her and then get back to Yaroslav with this question.
Okay. Any other questions? Please feel free to ask since we really have some time.
Hello, Yulia.
Yeah?
May I ask? Hello, Yulia, it's Edward.
Hello.
Could you switch to the slide 20?
Mm-hmm.
What is on X axis?
This one.
Topic number.
Yeah, topic number. So
don't you think that it's a rank value, but not a numerical one? So Kolmogorov test is not suitable here.
Which test? I'm sorry.
Kolmogorov, previous slide. Could you switch previous one?
Mm-hmm.
So you try Kolmogorov-Smirnov test, aren't you?
Well, yeah, actually it was again my colleague Anastasia who did that.
Well, maybe you should discuss with your colleague applicability of this test for your data, because they have ranking nature, but not numerical one. I bet $1 that I can re-rank your test and give you better result for p-value.
Okay, great. Thank you very much for this very valuable observation and or remark. That's now I'm intrigued as to what results we might get. Thank you very much.
I have a more general question. So the paper says that it is about identifying a metaphor using topic models, but actually the way that you describe your workflow, it doesn't seem to differ very much from word sense disambiguation. I mean, actually what you did is just classify word usages into senses. So does it really tell us anything about metaphor, or is it just an exercise in word sense disambiguation?
Well, there is a definite and a definite overlap between these two tasks, word sense and disambiguation and metaphor identification. However, all systems and all projects for metaphor identifications are conceptually structured like this. The major difference between word sense disambiguation and metaphor identification is that in this case we divide all senses of a word into two larger beings, and we expect that the context of the word senses which we put into the metaphoric being, they have something in common, and the senses in the non-metaphoric basket also have something in common, because words have in most cases words have more than two meanings. Even our target verbs, when you look at them, they might have up to as many as 10 or even more meanings. So if 7 of them are non-metaphoric and 3 are metaphoric, then we think that there is something in common with the for each of these types. I don't know if I answered your question.
So does it mean then it's just word sense disambiguation with granular senses? So it's just kind of word sense disambiguation made easier by combining or merging several senses into one. But yeah, I mean, it is not to diminish your work. It's just that it seems that technically the task is more or less the same.
Oh, I'm sorry. Yeah, yes, but much of the metaphor identification research also pursues the goal of putting to test the assumptions, the theoretical linguistic assumptions about metaphor, such as the presence of these conceptual schemata, for example, in case of topic modeling, or when we apply concreteness and abstractness, for example, we expect to see that metaphoric discourse is less concrete and more abstract than non-metaphoric. Or when we look at the lexical at the lexical cues, we attempt to detect or harvest to harvest some psycholinguistic cues indicative of metaphor. So there is a research purpose as well, not only the purely applied one.
Thanks. Any other questions? Okay, just a quick follow-up question. Can you imagine any ways to actually detect like more specific properties of metaphor, like source and target or vehicle or whatever? I mean, something specific for metaphors.
With the topics?
Well, with topic modeling or whatever.
Well, yes. Overall, there is we are now working in the bottom-up paradigm. When we look at the data, and at the first step, we try to separate metaphorical occurrences from non-metaphorical ones. And then at the more advanced stage, if we decide to move on, well, not us, but any researcher, we can try and induce sources and targets, or proto-sources and proto-targets by clustering the features, or by generalizing them. And then so we can try and induce these conceptual mappings from data, rather than when we work top bottom, when we take Lakoff's master metaphor list and we take them for granted a priori, and then go to the data and try to find the matching patterns in the data. This approach, which is frequently criticized for a certain bias towards subjectivity and intuition.
Okay.
Thank you very much.
If there are no other questions.
Oh yes, all the scripts and resources related to this project are available in a GitHub repository. I think I forgot to add the link. Okay.
Okay, thank you for this very interesting talk. And we will move on to the last talk in this section, which is generating sport summaries, a case study for Russian. And I guess Valentin Malekh is presenting, right?
Yeah, that's me. A few seconds, I'll.
Sure.
Sorry.
And if possible, can you please turn on your camera?
Yeah, of course. Few seconds. I just need to